guys, welcome back to my YouTube channel. So today I'm going to explain to you how you should answer all the class activity for our last chapter for this semester, electrochemistry. So altogether now we have 6 different questions, and let's start with the first one. Question number 1. Determine the oxidation state of magnesium in MgO2 and ferrum in Fe2O3. So, how are you going to answer this? Let's get started. So, we are going to tackle the first one first. You have the compound of MgO2. Alright, so you know that oxygen have a very specific oxidation state. So if it's being binded to another elements, it means that the oxidation state shall be -2. So it means that equivalent to magnesium oxidation state plus oxygen is -2 because you have 2 oxygen here times 2. Therefore, it should be equivalent to 0. Why 0? Because this one have no charge at all. So you can say that magnesium is actually equivalent to -2 times 2 equivalent to -4. But since we are going to put it here, it becomes +4. So magnesium oxidation state in this compound is +4. Now moving on to the second one, Fe2O3. Same goes. Fe2O3 have no charge around here, means that the oxidation, the total one is 0. So since oxygen is being binded to another one, means that it's still -2. So it means that Fe, because you have 2 Fe times 2 plus -2, the oxidation state for oxygen, because you have 3 oxygen here, times 3 equivalent to 0 because there's no charge. So 2 Fe is equivalent to 3 times 2 equivalent to 6. So going over there, so +6. So you will get your Fe equivalent to +6 divided by 2, +3. So this is the answer for the first question. Question number 2. Hydrogen gas and copper 2 oxide react to produce copper metal and water. Determine the oxidizing and reducing agent. So how are you going to answer this question? First and foremost, you need to write the balanced chemical equation. So we have here copper 2 oxide react with oxygen. So copper 2 oxide react with hydrogen. States here it will produce copper metal and also water. So it will produce copper metal, which is in solid form, and water. So from here, you were asked to determine which one is the oxidizing and which one is the reducing agent. So when you have these kind of things, so this one, you need to look at the copper itself, like copper, and then the other one is definitely the hydrogen gas. So we are going to tackle on copper first. So copper oxide is equivalent to 0. It have no charge, right? So at first, copper oxide, so copper plus same oxygen -2 equivalent to 0. So your copper, the oxidation state for copper is actually +2. So and then if you can remember, if it is in the element itself, so it means that it's the oxidation state shall be equivalent to 0. So from +2 to 0. So reduction, right? It follows a reduction reaction. Okay, let's look at hydrogen. So hydrogen, H2, and then it will produce H plus, right? Why H plus? Because from the H2O is H plus plus OH minus. So you have the H plus over here. So since you have 2 here, means that you have 2 H plus. So because this one is H plus, means that it needs 2 minus 2 electrons. So in this reaction, you are going to donate 2 electrons to make it into ion. So when it made into an ion, means that this one, the oxidation state is 0, right? No charge, turning to positive 1. So it means that this is oxidation. Okay, and then we need to look again at the question. Determine the oxidizing and reducing agent. When it comes to agent, it's going to be the other way. If it follows reduction, it means that this is an oxidizing agent. While if we undergoes the oxidation, means that this is reducing agent. Right, so this is the final answer for this question. It means that the oxidizing agent is actually CuO and the reducing agent is H2. Moving on to question number 3. Hypothesize the half reaction and the net reaction for the reaction below and calculate the inert cell for the reaction. So given to you is this figure 3, which is the voltaic cell. So the first thing that you need to look at is the electrode. So we have 2 electrodes here, which is the zinc electrode and also the copper electrode. So from here, you need to know which one is the anode and which one is the cathode. So how are you going to determine which one of these shall be the anode and which one shall be the cathode? Is by looking at the standard reduction potential. It's in your question itself. So from this list, you need to look at 2 different things, which is the zinc and also copper. So the zinc is here, negative 0.76. And then the copper Cu here, 0.34. And then you need to remember the one with the most positive value shall be the cathode. So the cathode must be the positive. So in this case, the cathode must be the copper to positive, right? And then the cathode, remember the tips I give you, red cat, right? The red cat reduction occurs in cathode. Alright, so now we know that the zinc is anode and the copper is cathode. Right, so I'm going to write anode, cathode, and then this is the net reaction. Now I'm going to explain to you how to write the half reaction and also the net reaction. In the half reaction, you should have anode and also cathode, and in the net reaction is actually the combination of anode and cathode. From here, you can actually calculate the inert cell for this particular reaction. So from looking at the reduction half reaction, we know that the zinc shall be the anode because it is more negative, and the cathode, which is more positive, is supposed to be the copper. And then the tips that I have given you in the notes is that red cat means that reduction occurs in cathode. So when you look back at the reduction half reaction here, for the copper, you will have no problem. You just need to copy because there's no changes needed because this is the reduction half reaction, right? So reduction. So you will have Cu 2 positive and then plus 2 electron will produce the copper, the solid copper. So from 2 positive become 0. That is reduction. But when you look at anode, for the zinc, here given to you for the zinc is actually 2 Zn2 plus 2 electron will produce zinc. This is a reduction process. But now you should change it to oxidation. So you need to change the position. So instead of doing the reduction, you should write in the oxidation state. So Zn minus 2 electron shall produce Zn2 positive. Okay, now what else that we need to do? We need to write the E node cell. So the E node cell. So this one we need the E node cell as well. Okay, for this one, because we don't change anything, so the value stays the same at positive 0.34. But zinc, initially, if you look at the table, the value should be negative 0.76. But that is for reduction. So since we have twisted this equation, this one become positive 0.76. Alright, so make sure that this one you change to positive. Alright, what else should you do is negative 2 electron plus positive 2 electron. So you can slash this out. So you just can copy. So zinc plus copper 2 positive will produce Zn2 positive plus Cu, and then the E node cell is equivalent to the summation of this, which is 1.14. So how you going to get this 1.1 is 0.76 plus 0.34 is equivalent to 1.14. So this is the answer for your third question. Question number 4. So these are the sketch of an electroplating setup. So briefly explain how electrolysis can help to plate the spoon with silver. Your answer needs to explain on the electron movement, anode, cathode of the setup. Alright, so now this is a simple electroplating setup. So the first thing that you need to understand is that when you do an electroplating, so one part shall be like the thing that you are going to coat, and the other one is the metal that you want to coat it with, right? So now it given to you is you want to coat the spoon with silver. So in an electroplating setup, you need a battery. So this part is the crucial part that you need to show me where is the anode and where is the cathode. So remember, in electroplating, the spoon should always be in cathode because red cat, remember, reduction occurs in cathode. It means that it will produce the solid. The solid must be electroplate on the spoon. So cathode for battery, this is like in schools, right? Battery we have positive and negative. The short one is the cathode, negative. So battery, so it means that this one should be linked to your spoon, right? So the other one should be linked to this electrode, which is silver. What is silver in chemistry? Is argentum. So you need to label this argentum and you need to draw this battery. This one is cathode and this one is anode. So I'm just going to write here negative, this one is positive. So electron movement, where will the electron move? From where to where? Electron move from positive to negative. So electron move from here, going here, going here. Okay? Alright, so you just have to complete this. Okay, the next thing that you need to do is you need to write the anode and cathode. Okay, so in terms of this, because it is an electroplating process, so both shall be looking at the silver, at the argentum itself. So you have anode, you have cathode, and then you need to remember again, red cat. Reduction occurs in cathode. So reduction. So argentum is argentum plus. So plus electron. So it will produce argentum, the silver in solid form. And in anode, it shall be the other way around. Means that the argentum itself, this one, the solid. So again, the red cat, right? So argentum plus the ion will plus electron. See the electron movement here, and it will produce the argentum or the silver in solid form. But in anode, you have this solid silver, so solid silver, and then it will remove, right? Remove electron, so minus electron. It shall produce the Ag plus. Okay. So this is the way you should answer question number 4. Question number 5. Calculate the equilibrium constant Kc for the reaction between cadmium and copper at 25 degrees Celsius using standard reduction potential. So the same thing goes, you need to look at the standard reduction potential. So this is the table. So what is it that you're going to look at is between the cadmium and also the copper. So cadmium, the cadmium is negative 0.40, and then copper again, copper is 0.34. So the most positive one shall be the cathode because it will undergo reduction. So we know now the cathode shall be the copper and anode shall be the cadmium. Okay, now let's go and write anode, cathode, and then we shall have the net reaction. So what shall it be? So according to this table, we know that the cathode is the copper. So if it's reduction, you just have to copy. It's easy. So plus 2 electron, you will have solid copper with the anode equivalent to positive 0.34 volt. Alright, and the anode, because in the table it is reduction, but you know that in anode it occurs, it follows the oxidation. In cathode, it's very straightforward. You can just follow the table. You do not have to change anything because cathode follows the reduction reaction. But in anode, because you know that in anode you will follow the oxidation instead. So you need to twist the equation. So from deduction, you need to write the oxidation reaction instead. So cadmium minus 2 electron shall produce cadmium ion with anode equivalent to positive 0.40 volt. Alright, now we are going to write the net reaction. You see the electron is balanced, right? So negative 2 electron, positive 2 electron, you can slash this out. So you can write the net reaction is cadmium plus copper 2 plus will produce cadmium 2 plus copper, and then your anode cell shall be equivalent to 0.74 volt. It should be positive. Alright, so it's just summation, so 0.4 plus 0.34, so you get 0.74 volt. And then look again at the question. The question asks you to calculate the equilibrium constant, the Kc, between these reactions. So this is not the end, you just have calculated the E node cell. So from there, at equilibrium, you can assume that the E cell is equivalent to 0. So E cell equivalent to 0 because this is at equilibrium. So then you can calculate the E node cell, which you have calculated just now, is equivalent to 0.059 divided by n log Kc. Alright, the E node cell you already calculated just now, which is 0.74. So this one, 0.059 divided by n. What is n? How much electron is there? So 2 electron plus 2 electron means that is 2 over here. Log Kc, the thing that we want to calculate. So 0.059 divided by 2. So you get 0.74 equivalent to 0.0295 log Kc. Alright, from here Kc, how are you going to do it? Is 10 to the power of 25.0847. So you shall get, the final answer is 1.2153 times 10 to the power of 25. This is your Kc. Question number 6. A current of 0.5 ampere was passed through a solution of copper sulfate for 1 hour. Calculate the mass of copper metal deposited on the cathode. So, to answer this question, first and foremost, you need to know what is the current given and also the duration of it so that you can calculate the Q. So, the current given in the question is 0.5 ampere, and then the duration given is 1 hour. So this 1 hour, you need to convert it to second. 1 hour is 60 minutes. Every minute is actually 60 seconds. So it should be 3600 seconds. Alright, so now you're going to calculate the Q, the current, right? So the Q equivalent to IT. I is the current, which is 0.5. T is the time in second, right? So 3600. So you get your Q equivalent to 1800 coulomb. Alright, so from here you need to convert to Faraday. So this is a constant value, 96,500 coulomb is equivalent to 1 Faraday. So since you only have 1800 coulomb, means that 1 over 96,500 times 1,800. So you should get 1.03627 times 10 to the power of -5 times 1,800. So you should get 0.0187 Faraday. Okay, this is the first part of how you should answer this question. Okay, from this question, it uses CuSO4. Therefore, what that will be deposited shall be the copper, obviously. So, we can write the chemical equation as Cu2 plus 2 electron shall produce the copper in solid form. So, the number of electron that plays a role here is actually 2 electron. So the number of electron is actually how much Faraday that you need. So since we have 2 electron, means that is equivalent to 2 Faraday. So in every 2 Faraday will produce 1 mole of copper. So 2 Faraday will produce 1 mole of copper. Okay, so we have how much Faraday? We have 0.0187 Faraday. So how much mole of copper that we will produce? So 1/2 times 0.0187 Faraday shall be equivalent to 9.35 times 10 to the power of -3 mole of copper. This is how much copper that is going to be deposited. But in the question, you were asked to calculate what is the mass of copper. So how are you going to do it? Is by using the formula number of mole equivalent to mass over RMM. Alright, I'm just going to do a quick recap. Just now, how are we going to calculate it? By looking at the number of electrons. So you know that it's Cu 2 plus 2 electron shall produce copper, right? And then since we have 2 electron over here, it means that we need 2 Faradays to produce 1 mole of copper. If you have 1 electron, means 1 Faraday to produce 1 copper. So from here, we said that 2 Faraday shall produce 1 mole of copper. And then because we have this 0.0187 Faraday, so we shall have 1/2 times 0.0187, which is equivalent to 9.35 times 10 to the power of -3 mole of copper. Right. But the question asks you to calculate what is the mass. So the number of mole is actually equivalent to mass over RMM. So the number of mole is 9.35 times 10 to the power of -3, equivalent to the mass over RMM. So the RMM for copper you can find from the list in table 1. So you're going to find copper. Where is your copper? Here. So 63.546. 63.546. So the mass shall be this one times that one. So 9.35 times 10 to the power of -3 times 63.546. So you shall have the mass equivalent to 0.5942 gram. So this is the final answer for your last question in the class activity. So thank you very much for watching this video, and good luck for your quiz tonight. So I'll see you again next week.